Okay, let's go ahead and go over homework 9. Can you explain to me why atoms become ions? What's the purpose? What's the reasoning behind the atom becoming an ion?
The loss or gain of an electron.
Okay, so they become one by losing or gaining electrons. And why do they do that? Why do they go off and lose or gain electrons? What's their so they can what?
React with another atom.
The losing and gaining is reacting. So why are they reacting? They want the electron configuration in noble gases. So they want to become stable. So since we know the electron configurations for noble gases are stable, the atoms themselves are trying to attain that same stability. And once they reach that, then they're happy. They're as electronically stable as the noble gases. Does an atom that has reacted no longer have the ability to react? What do you think? No?
Once it's reacted, it's lost or gained an electron.
Uh-huh.
It's stable. Why would it react?
Okay, I will go with the fact that it's less likely to react for sure, but does that mean it's not going to react? So, can you imagine that every single atom in the universe has already reacted at least 1,000,000 times? If the universe is billions and billions of years old, that they're still reacting. So what is it about them that allows them to react once they've lost or gained electrons to get to noble gas configurations? Let's use carbon as an example. So carbon in the form of, say, glucose, those carbon atoms have lots of electrons and they give them away until they've got a helium electron configuration. And is that it? Is that the end of the story? Once it's turned into CO2, is it useless and can't be used for anything? No? What is it that uses it? Go ahead.
CO2.
Okay, so photosynthesis allows the electrons to be put back on the carbon atom, thereby kind of making the carbon atom unstable, right? So, but how does that process, what's the impetus or what's the push behind that process?
The sun.
The sun, right? So they don't react unless you do what?
Give them another source.
Or give them a source of energy, input energy. So these things give up their energy without any input whatsoever. They'll just do it. A piece of wood will burn. You don't have to add energy to keep the wood burning. It just burns. But then once it's burned into CO2, how do I get it to turn back into wood? I have to put a whole bunch of energy into it, right? So you can get them to react, but now it takes energy to get them to react. Which atom is more likely to gain electrons in a chemical reaction between silicon and bromine? Can you explain why?
Bromine.
Why is bromine gaining?
Because it only needs one more to gain to become a noble gas. Whereas silicon needs more.
How many does it need?
Four. Yeah, 4.
So since silicon needs more, it's less likely to attain. So it'll do whatever the other substance wants. Silicon is going to behave very similarly to what other element? Say again? Did you say diamonds?
Metals.
Nope, not metals. It should be like
Carbon.
carbon, right? It's in the same column, so it's going to behave very similarly to carbon. So there was an episode of, I don't know, I think Star Trek New Generation, where they came across silicon-based life forms. So if we're carbon-based life forms, is it conceivable that there could be silicon-based life forms? Yeah. Silicon behaves very similarly to carbon, so if the conditions were correct, maybe silicon would have been the thing that all the atoms, all of our molecules were based off of, but, and it's all because of their similar reactivity. Okay. How many protons and electrons are found in a sulfite polyatomic ion? So the sulfate polyatomic ion is what? SO3 -2. So how many protons do I have?
40, 40.
And that you get that number from what?
16.
I get 16 plus 8 plus 8 plus 8, right? Is that 40? 32? It's 40? I think it's,
8 times 3 is 24.
oh yeah. All right, so we got 40 protons. And how many electrons must we have?
42.
We must have 42 electrons because this is a -2. So whatever my proton number is, or whatever my proton number plus 2 gives me my electron number. So what did these 4 atoms do? Together they took 2 electrons from some other stuff, right? Again, don't let the fact that it says -2 means that it's lost anything. The -2 actually means it's done what?
It's gained.
It's gained 2 electrons. The negative doesn't refer to gain or loss of something, it refers to charge.
Okay.
What are these bugs are driving me crazy today.
I'm not wearing white. I did that the other day. I was covered, like literally covered in stupid cats.
Because you were wearing white
I was wearing white. I don't know what it was.
and they were
I
just
wore
all
it
over you?
And they don't leave me alone. But I wore white everywhere.
I know an entomologist, I'll have to ask him about that.
Probably my bad.
Is that when, just a quick question on that, is that when you said the other day about them conspiring to take 2 away from everybody else? Those 2 came together and that's another.
Well, these 4 atoms,
Four, sorry.
those 4 atoms, when they came together, they also took 2 electrons from something else. How about an ion definition? Okay, how about this? The protons and the electrons do not equal each other. Right? I don't care what the numbers are, how they don't equal each other. As long as they don't equal each other, you got yourself an ion. And a molecule?
Any atoms.
And the protons and electrons do equal each other. Right? Cation?
More protons than electrons.
That is excellent. And more, and the anion?
Plus.
We good with that? Why would lithium be happy to form a compound with bromine?
Lithium needs to get rid of an electron and bromine needs to gain one.
If I spell it right. Okay. Electron configuration before it reacts with bromine. So then I've got Li 1s2 2s1. And after it's Li plus 1s2. We good with that? Why am I putting that superscripted plus on there?
Because they gave away an electron.
Giving away an electron, now it's got positive charge. It's got 3, it still has the 3 protons it always had, but now it's only got 2 electrons. And my bromine, let's scroll down to that guy. I've got Br, 1s2, 2s2, 2p6, 3s2, 3p5. And then afterwards, it's bromine with a negative charge. 1s2, 2s2, 2p6, 3s2, 3p6. So whose electron configuration do we have for the lithium after it's reacted?
Helium.
Heliums. And for the chlorines after the reaction? I'm sorry, the bromines.
Argon. No, krypton.
This is wrong. For some reason I was thinking chlorine. So this is a 6, and then this is 4s2, and this is 3d10, and then this is 4p5. And then it's bromine negative charge, 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6. And so we've got, once the bromine has become an ion, it's krypton's electron configuration. Okay.